We have these parts in IP addresses. Okay, and you said that the net ID or subnet ID is something similar to family name. Okay, name of family, and host ID is something similar to the name of a child in family. For example, I'm Hossein Ghaffarian. My name is Hossein. My host ID is Hossein, and Ghaffarian is my family name. So it's my host. It's my net ID or my subnet, and we said that okay, to make it clear which part of bits in an IP address is related to the subnet and which part is related to the host ID, we are using mask, subnet mask, and we show it in this way. For example, like this, a slash, for example, 24. It means that the first 24 bits from left to right, the first 24 bits are net ID part or subnet ID, and the rest of bits, the rest of 8 bits are host ID. Okay, because totally we have 32 bits in an IP address version 4. The first 24 bits are related to the subnet ID, and rest of them, the 8 remain bits, are host ID. So we use this notation, a slash notation, here to make it clear which part is related to the subnet. And we said that each network has its own net ID. Okay. For example, here look at this picture. Here we have three networks. Okay, we put a subnet to each of them, and also we have 3 connected links, 3 connections here. Okay, we can call them as a separated network, each of them. So in this picture, you can see 6 different networks. 3 networks on the top and bottom of this picture, and 3 networks just for the links in this image, the links between those networks. Okay, so we can have different networks with different sizes, with different number of IPs. For example, in a link, something like this, in a link, we have used 2 separated IPs. We need 2 separated IPs because it's a direct link between a source and a destination. So we need 2 IP addresses. But in a large network, we have more addresses. We need more addresses. Okay. Okay. Using this strategy to determine the number of bits for host ID or net ID, we can go we can present a new concept in IP addressing, which is we call it CIDR, or classless interdomain routing. What does it mean? What is CIDR? In CIDR, we say that, okay, assign IP addresses in a network just based on your needs, no more than your requirement. Okay. For example, here again in this picture, for these three links, three connection links, we can see that we are applying different IP addresses to those networks, and we can see that those networks just need two IP addresses. But here, the mask of this network is S/24, which it means I can have 256 different IP addresses in this network. I only need two addresses for these type of networks. Okay? But in reality, this network can have 255 different IP addresses. Okay, most of this range is not necessary. So we use CIDR concept strategy. In CIDR, it says that, okay, use IP addresses as much as you need. How? It's simple. Just define the host part, or define the size of host ID. The rest of bits belongs to the net ID. For example, yes, for example, in this case here, in this example, here, you can see I'm using only the first 23 bits as a subnet part, or as a subnet ID, or mask as a net ID. Okay, it means that 9 bits remains for the host part, or host ID. And so in this network, I can have 512 different IP addresses. I have 9 bits in the host ID part, with 9 bits I can present 512 different patterns. Okay, different IP addresses. So just as much as you need, you can assign IP addresses based on the requirement. No more than the requirement, no less than the requirement. Just putting just assign IP addresses based on the requirement. Okay. For example, in here in this links as a network, I have to use /30 trouble mask. It's not necessary to assign a /24 bits to this network because I don't need them. Okay, they are not necessary. Okay, so I can do this, but here I said that okay, here I need 2 IP addresses, but I said that the mask of this address is /30. But why? Why it's not /31? In a network, always in a network, the first IP address and the last IP address in the range of IP addresses in a network. The first IP address and the last IP address in a network are not accessible to assign them to a system. The first IP address in a range, in a network, is dedicated to for example, let me okay. For example, the first IP address in a range. I have a network. The first IP address in that range has a couple of 0 in the host ID part. A couple of 0 in the host IP part. Something like this. Look at this. The host ID, the host ID part is completely 0. This is the first IP address in a network, or the beginning address of a network. I cannot use this address to assign it to a computer. Okay? So the first address is the address of that network. And the last address in a network is an IP address with a couple of 1 in the host part, in the host ID of the address. For example, if I try to find the last IP address of this address, I should say, okay, the last one is this. Okay, look at this one here. Instead of in the first IP address, you can see a couple of zeros in the host part or host ID, and for the last IP address, you can see a couple of 1s in the host part or the in the host ID. This is the binary notation. If I try to write it in decimal notation, I should write it as 200.23.17.255. /23. This is the source, this is the beginning address in a network and ending address in a network. Begin. The begin address and the end address. Begin and end address. I cannot use these two addresses to assign them to a computer. Okay, so it means that in a network, always in a network, I have used at least 4 IP addresses. Why? Because I need 2 addresses here for the beginning and end address as a beginning address and end address in a network, in a subnet, and at least there is 2 machines, 2 computers to connect together. What is the end address? End address is the broadcast address of a network. Broadcast address. Broadcast address in network. Okay. I cannot use these addresses, so in a network, at least I need 4 different addresses. 2 of them for beginning and end address, and other addresses, other 2 addresses are for assigning to the computers in a network. So for a link, something like this here, I can use a subnet mask of 13. Instead of having 24, I can say /13. Okay, it's better for me to manage these resources. Okay, how an IP address works. I'm looking for an IP address in a network, okay? And maybe I decided to uh, get an IP address. So actually I have two questions. The first one, how does a host get IP addresses within its network? And the second question is this, how does a network get IP address from itself? These questions means that if I'm adding to a network, how can I get a new IP address? Maybe you assign an IP address by hand, manually, okay? But in today's network, we have a special service, we call it DHCP. Dynamic Host Configuration Protocol, DHCP. Look at its name, Dynamic Host Configuration Protocol. What does it mean? It means that this service is run dynamically in a network. When I'm adding to a network using a DHCP server, I can receive an IP address. And when I left the network, my IP address would be free to use for the rest of systems in the network. This protocol or this service can assign IP addresses dynamically to the host. Or maybe the host asks for example, to renew their current IP address or reuse an IP address again, or some systems are mobile IP systems. Okay, they are mobile users. So when they visit my network, I should give them IP address in the range of my network. Okay. But how does it work? How does DHCP works? Firstly, the host broadcasts a DHCP message, this DHCP discovery message. The DHCP server would will respond to this discovery message. Okay. Then the host requests IP addresses. And finally, after the host request for an IP address, the DHCP server sends the IP address to the client or to the user. Look at this one, for example. This is a mobile host which is joined to, for example, this network. So it must receive an IP address in the range of this network, because currently it's a part of this network because it's assigned to a specific network. This chart here presents the steps of this message passing mechanism in DHCP. Okay. One main point: a DHCP can do many things. It's not limited on just, for example, it's not limited on IP addresses. Okay. When we are using DHCP, we will receive the IP address of the first router in the network in allowing my pass. Okay. The name and IP address of the DNS server, and also we can receive the network mask. As I said, we need this mask. Okay, let me, please wait for a minute. I will be back. Okay, just wait for a minute. Yes, hello. We are using DHCP server in our network to assign the IP addresses dynamically to the computers who are entered to the network. The DHCP server is responsible for assigning the IP addresses to the computers uniquely. And as I said, in the range of IP addresses in a network, I cannot use two of those addresses, the first address and the last address. I cannot use these addresses, and but I can use the rest addresses. The DHCP server use the rest of them to assign the IP addresses to different computers. Okay. Here you can see, for example, a laptop is coming or connecting to a network. Okay. Then it tries to use the DHCP protocol to ask its IP address in the network. Okay. And here on this router, the first router in the network, in this router, you can see there is a server. There is a DHCP server. It records the information of this, for example, laptop or new arrived computer, and then it can respond to this laptop and it is said, okay, your IP address, for example, is something blah blah blah, something like that. Okay, but how I can broadcast a message in a network? If we are standing in the layer 3 of a network, I said that the last IP address in the network is dedicated for broadcast addresses. Okay, but when we are standing in layer 2, the layer 2 of network, for example, in the Ethernet, okay, at this time, we can use a MAC address with completely full of 1. Okay, for example, something like this. Look at this. The destination MAC address of the receiver is something like this: F F F F and completely F. What is this? If you bring this address into binary, you can see this address is consists of 48 1. The whole address is completely it is 1 in binary when I'm showing it as in binary notation. So in layer 2, when I'm looking for broadcast address, just simply I'm putting 1 for all the bits in the address. Okay, you can read this example here, how the server answer to the laptop, and how this laptop can get its new IP address. Okay, but let me talk about something else. Okay, I can receive my new IP address, but what about the space of addresses in a network? For example, I'm an administrator in a big ISP. This ISP buy a new range of IP addresses, something like this. For example, 200.23.16.0/20. Okay, this an ISP buys this this range of IP addresses. Here you can see the binary notation of these addresses. Okay, and this ISP decided to divide this space between 8 different likes, or between 8 different networks. How can I do this? So the question is this: I have a specific range of IP addresses, and now I want to split this range between some networks. How I can do this? Okay, it's very simple. Just you need to be clear about something special here. For example, here they ask me to divide this block into 8 different parts. I know that 8 is equal to one. 2 in power of 3 is equal to 8. Okay? I know this one. What does it mean? It means that I need, oh, excuse me. This means that I need 3 bits to make it clear which of those 8 blocks I'm talking about. I want to talk about one of those blocks. Okay, I need 3 bits to define them, define each of them. Hear my sound? Okay. Okay, then I'm saying I need X different blocks of IP addresses. So you need to solve this equation. Log of X in base of 2, just find the ceiling of this equation. Just solve this one. For example, here, wait. For example, here, I'm using 8 blocks. Log of 8 in power of 2 is equal to 3. So I need 3 bits to define one of those 8 blocks. Okay. I have different blocks, different 8 blocks. I want to define one of those blocks. So what does it mean? It means that I need to extend um, let me, I need to extend the network part or subnet part. What does it mean? For example, let me show you. Let me show you. In the first, in the primary address, the host part, the net part or subnet part consists of 20 bits. And now I need 3 more bits to define one of those 8 blocks. So I should sum them, and now you can see the subnet mask in the network is increased to 23, 20 bits for the primary mask, and now I need 3 more bits to define one of those 8 blocks. So the mask of network, the mask of those 8 subnets is 23. Okay? Look at this one here. In the first networks, just I'm using this one, and look at this one here. This is 20 bits. And now I'm looking for another 3 bits. Look on this, look on the green zone here. By using 3 different bits, I'm making it clear which of those blocks I'm talking about, which of those blocks. For example, when I'm talking about the first block, you can see the first block, the 3 bits for the first block is 000. For the block 1 is 001. Block 2 is 010. For example, for block 7, it's 111. It's a binary notation. Okay? Using a binary notation, I'm make it clear which of I'm talking about, which of those subnets, just using those 3 bits. But when I'm changing these binary notations into decimal notations here, you can see, okay, Ale, Naim, I know. Okay, I will put some some minutes to answer your questions. Don't worry about that. Okay. So simply, I need 8 blocks. I know that to show those 8 blocks, I need 3 bits. So I'm extending the subnet ID from 20 to 23. I'm adding 3 bits to the subnet ID, subnet mask or subnet ID, and using those 3 bits, I'm defining those 8 blocks. So I'm reducing the space for the host ID. Look at this one. The red zone is the space for host IDs. Host ID. The green zone is for subnets. New subnets. Okay. We call this strategy as subnetting. We call it as subnetting. this process is subnetting in computer. We divide in a large address into some subnets. Okay, so this is subnetting. But when you are going toward the core of the internet, we are using a reverse process. We call it supernetting. Supernet. Okay, call it supernet. Subnet and supernet. Excuse me. Supernetting. So if I divide an space into some smaller space, I'm doing subnetting, and in reverse, if I join some subnets, some small ranges into a bigger range, I'm doing supernetting. Why this is important for us? We do this subnetting or supernetting because when I'm going toward the core of internet, I can aggregate the routes. And it's very important for me. Why? Because when I'm standing in the edge of network, in the edge of internet, there are several or maybe thousands of networks at the edge. But when I'm going toward the core, the routers in the core should learn about all of those networks, which is not easy. Instead of that, we are doing route aggregation. By route aggregation, I'm aggregating those separated small spaces into a bigger one. For example, this one. Look at this. I have 8 different blocks. I'm aggregating them into one bigger block. So a router in the core just needs to learn about this big address. He doesn't need to know those 8 addresses. Instead of 8 addresses, he needs to know only one address. So by this strategy, I can reduce the size of forwarding table or routing table in the core routers. In current core routers, more than 1 million records are presented in the forwarding tables of core routers. Okay, more than 1 million records. So route aggregation is very necessary for us. And here, simply we can use route aggregation to make a hierarchical addressing strategy. Here, my packet can go through this space here until to this network, and then I can specify, make it. I can make it clear which of those subnets is the destination of this address. this packet, for example. Okay. So those hierarchical addressing strategy is good for us to make it clear the route of packets too. But one main question, let me talk about one main question as the last things. Okay, about the IP addresses. Look at this one. A packet arrives for destination 200.23.18.0/23. Okay, if you look on this address, you can see here this packet comes from internet. Okay, you can see I have two different routes. One route from the top network, the top route can bring the packets into the organization one, and another route comes from another ISP. Directly it comes to the organization one. It means that this organization, organization number one, is connected to the internet through two different passes. One, for example, one pass is routed through fly-by-night ISP, and the other pass comes from RUS, for example, ISP RUS, something like that. Okay, but I should select which of those routes, the top route or the bottom route. Here, we choose the bottom route. Why? Why we choose this route? Look at this one. Here, the mask of this address is /20, and here the mask of this route is /23 bits. It means that if I choose the bottom route, the route from ISP's RUS, more bits, look at this one, 23 bits instead of 20. More bits in the address are matched with my address, with my destination address. More bits are matched. We called it longest prefix match, or LPM, longest prefix match. Always we select the passes with more number of bits who are matched with my destination addresses. The pass, the above pass, the top pass, only matched with my address in 20 bits, and in the bottom pass, my addresses is matched with 23 bits. It's longer than the top address, top route. So I'm choosing the bottom route. But why? It's simple. As long as my address matches with more bits, it means that I'm closer to the destination. Why? Because of route aggregation. Because of route aggregation. Look at the one here. Route aggregation. Here, the mask of networks was /23, and after route aggregation, the mask is /20 bits. Okay. So if I found a route with more matched bits, it means that this route is closer to the destination. So we choose the route with longest prefix match. Okay, about the NATs, IP addressing, and other things, you can follow the instructions defined by ICANN. ICANN is International Corporation for Assigned Names and Numbers. It's an international organization, okay, which registers all the IP addresses assigned to different companies, different organizations, different networks. It's a manager of all of those IP addresses and URLs and something like that. Both IP version 4 and IP version 6 for both of them. It's responsible. So please visit the site of ICANN at icann.org. Visit this site for more information. Okay. Right now, I'm finishing the today's course, and okay, let me know what is the time in Iraq.